Hey guys, hello everyone. Welcome to this webinar. This time we will take a look at remote access with AnyConnect. And I want to take a look at a couple of things in this session. I'm Piotr Kaluzny. I'm going to host this session for you guys. I'm one of the security instructors here at INE. As I said, I want to take a look at a couple of things in this session. We will make an overview of this technology, VPN technology. I want to make sure that everyone knows what remote access is and how is it different from the other type of VPN deployments, which is site to site. We will also look at AnyConnect, which is going to be the software of choice for the Cisco-based head-end devices. It's going to make more sense when I explain how this remote access setup actually works. And then we will take a look at an example. I will still want to show you how to get AnyConnect up and running with Cisco ASA. And in most cases, when you see an example like that, what people are showing you is ASDM-based configuration. I want to focus on a different method. I want to show you how to do this configuration from the command line. So we will not be using ASDM in any way. It's going to be a pure CLI configuration what I want to show you. You can't do it this way. It's actually not that hard to get it work as long as you know how to build, how to deploy the IV1 based remote access VPNs. This is for those of you guys who have some experience with VPN technologies and Cisco appliances. It's something you can do without using ASDM, and that's what I want to show you today. Okay, for this introduction, I want to start with describing remote access technology from a high-level perspective. This is just one of the two VPN deployment options. We've got remote access and site-to-site. Remote access is something that you will be deploying if you plan to provide access to the corporate network, like to the office environment, to the office resources, to the applications that are hosted within your company, maybe in the data center. It's a method of providing access to individual users through this logical type of a connection known as a VPN. Because VPN is a logical connection. This is something that we will build over someone else's network. In most cases, it's going to be the public backbone, the internet. In this case, the goal is going to be, as I said, to give access to the network for individual users so that people, as they connect from home, from any location, because the only thing that we will need to have in place for this solution to work is going to be internet connectivity. And as long as the AnyConnect is configured on the client stations, as long as you've got the VPN termination point, the VPN server connected to your network as a physical or even virtual appliance, those people should be able to use the public network to form this logical connection. And once they connect, they will get a sense of physical connectivity with the office, with the internal network. So this way, they will be able to access those different resources, applications you're hosting in your environment for this logical channel in a secure and scalable way. Okay, in case of remote access VPNs, there are going to be two components that we will have to think about as we deploy this solution. So we will have a device that acts as a VPN gateway or just a server, which is what, as I said, is meant to be connected to our internal network with our resources, applications, the other systems that we want to people be able to access. Okay, so this is what we own. Then this device is also going to be connected to the public backbone. And the other piece of this equation is going to be obviously the clients. And the clients, as we will see, they will always have to have some sort of software that they will be using to initiate, bring up the tunnel, to eventually form this tunnel with our gateway for the internet. So this is what's going to make the VPN. Okay, once this is up, they will get access to the internal resources for this encrypted connection. So as I said, it's going to be some sort of software that you will have to use on the clients. And excuse me. Let's go back one step. And now what type of software you will have to install, you'll have to use, is going to depend on the security protocol that you will want to use for the deployment. You can either build these remote access tunnels, with SSL/TLS, or you can go for IPsec. And now one additional note on SSL/TLS stuff. Technically speaking, today it's the remote access, the protocol itself is known as TLS, which stands for Transport Layer Security. But it's in most literature, in most books and documentation, you will see that it's actually called, SSL VPNs. But SSL VPNs, again, it's the SSL is basically the old term, and that refers to the original technology, the original protocol, where TLS is basically the improved version of SSL. It does the same exact thing. It's just some of the internals that were changed to make the whole protocol more stable and secure. So even that it's now TLS, in most places you will see the term SSL, just based on the fact that most people are familiar with SSL. They remember what SSL is, but not necessarily TLS. So what I'm doing typically is that I just put SSL/TLS, but again, it's as you'll see, especially on the new appliances, going to be just TLS, no SSL, what's being used in the background. Okay, now, there are going to be some differences between SSL/TLS and IPsec. And one of the differences is going to be how you can do the deployment with one or another technology, what type of software you will have to use to build the tunnels. And with SSL/TLS, there are actually 3 ways how you can deploy remote access. You can do it in a clientless way, which means that you will rely on a web browser. Web browser is going to act as the VPN software. So you'll have to specify the address of the VPN gateway, and you will use the browser to authenticate. Once you authenticate, you will get access to a special SSL protected portal where you will be able to run certain applications. You can also do the extension of the clientless method, which is known as thin client. A thin client is an additional software that's being deployed, sent to the connecting client over this clientless connection that extends the original capabilities of the clientless solution. Because the problem with clientless VPNs is that since you will always use a browser, you have to use a browser to access the content, the only applications that you will be able to present using this method is it's just those that can be quote unquote webified. Okay, so something that you can present for a browser, like HTTP websites in general, HTTP, maybe some email applications that work over web, like Outlook Web Access. So anything that you can access for a browser, you will be able to access via that clientless VPN. Within client, we do the extension. This Java applet is what makes an additional connection, what builds another SSL connection, SSL TLS connection in the background, which is generally capable of protecting TCP-based communication. So this is gonna give you access to Telnet, SSH, and I don't think it's gonna be every single application that is TCP-based, what you can access via thin client, but at least those which are supported by the underlying VPN software. So it's going to depend on the vendor what you will be able to access using this method. And of course, the clientless and thin client, this is something that is going to work for SSL/TLS VPNs. If you want to use IPsec to protect the communication, you will have to go for a full client deployment, which is still available for SSL TLS. Full client is going to work for both the types of protocols. A full client means that you'll have to install some dedicated software, which in case of Cisco is known as AnyConnect. So AnyConnect is going to make, as long as you want to do the full client option, you want to go for the full client option, the AnyConnect is going to do the second piece that we will need to build a tunnel. We need the software, and we need the server, the headend device, which is going to terminate the actual connections. And another thing people commonly look at as they select the right protocol, the right application for remote access is the actual capabilities of SSL TLS versus IPsec. Okay, so in most cases, it's going to all come down to transport, which is in favor of SSL TLS, since it's going to be TCP and optionally also UDP. And by default, it's going to be port 443, what you use for SSL TLS. Now, versus with IPsec, as we know, it's going to be initially UDP port 500 for negotiation. Then it may be either ESP, or if the devices involved in the communication detected a network error translation, we will potentially float from 500, we will go up to 4500. Now, since TCP 443 is typically open on the different types of filtering appliances you may use in your network, it's going to be basically, and this is also more, I would say, net-friendly solution. This is something that people commonly select over IPsec. The other thing you should look at is going to be the cryptographic functions used by, actually supported by SSL TLS versus IPsec. In case of IPsec, it's still going to depend on whether you want to use IKEv1 or IKEv2. The new appliances supporting VPNs, IPsec-based VPNs, they will typically just give you the ability of negotiating IPsec tunnels with IKEv2. So you will be able to possibly to select some stronger encryption functions, but it doesn't necessarily mean that SSL TLS is not able to negotiate, protect the data using strong authentication encryption methods. One additional thing I would also think about would be the performance offered by one or another method. Some of the, it's still going to depend on the platform and the actual vendor, but based on my experience, since IPsec was used throughout the years, many of those appliances are optimized for IPsec. Now, if you plan to use DPLS, which is just a flavor of TLS SSL, it's for UDP communication. It stands for datagram TLS. This is generally something that it requires some additional resources it needs some additional resources to properly work. So IPsec is going to be less resource extensive, I would say, with those hardware accelerators optimized for IPsec rather than SSL TLS. And sometimes you will be able to change this in the configuration. Like say you want to focus on SSL TLS, you want to sort of like optimize the engines for SSL TLS, but it's not always going to be the case. Okay, when we get closer to the end of this session, I will be actually showing you some of the additional documents. So it's going to make more sense if I want to show you this stuff. Okay, let's continue. Let's now talk a little bit about the AnyConnect client. This is, as I said, the additional software that we will have to install on our clients if we plan to go for a full client connection. The full client, just to make it clear, when you go for the full client remote access, it means that you will allow to tunnel all IP-based communication. So any application, any custom application you may want to use, you may want to make accessible to the connecting clients. You will be able to do it with full client. Any type of email software, databases, management, telnet SSH, it's all supported with AnyConnect in the full client deployments. The remote access VPNs is just one of the AnyConnect modules. AnyConnect is this software is actually composed of several different modules, and VPN capabilities is just one of them. It's probably one of the two core modules, I would say. Most people use AnyConnect for VPN connectivity. You can use it to build IPsec tunnels with IP2 only, or you can go for SSL TLS. Another important component is the network access manager module, which is what people use for a wired and wireless access, like when you want to round that 1X. And it's also possible to add some other modules, do web security with WSA on site in the cloud. You can do posture assessment, you can do umbrella, and some other things as well. Okay, now the way that we will be deploying the AnyConnect for our purpose, there are actually two ways how we can do this. You can download the software from the Cisco's website or from any other place where Cisco made it available. I think you can also access AnyConnect on the Microsoft Store and possibly a few other places. So as long as you download the software, you can obviously install it manually on the user workstations. You can do the pre-installation, or alternatively, you can go for what is known as network download, in which case you will allow people to use this regular SSL TLS clientless VPN to push the software, push AnyConnect to the clients. What it means is that people will have to connect to the headend using just a browser. And this is what they will do during the first connection. They will specify the FQDN of the VPN headend, or maybe its IP address, and then the ASA or any other device that supports this solution is going to push AnyConnect to the connecting client. And AnyConnect is going to require some configuration, but as we will see, the configuration is the most important settings for this configuration will be pushed along with the, after the client gets installed and attempts to connect, but they will be pushed from the head end as well. Okay, one of the most important things you will have to do when you install AnyConnect on the client devices, when you prepare AnyConnect for installation, is going to be to build a special XML file known as AnyConnect Profile. And AnyConnect Profile is something that is going to store certain configuration required by AnyConnect to run, at least to run for the first time. And this profile is something that you will typically build for individual groups of users, so not necessarily one profile for the whole organization. There are actually a couple different settings you will want to do, and when you define the profile, you will be able to select, specify the address of the gateway that a client should be using as they connect. You will be able to configure the protocol supported for the session, SSL TLS versus IPsec. You will be able to define a bunch of backup servers for redundancy and also customize certain settings that people will be eventually allowed, or choose what settings people will be allowed or not allowed to customize on their side. That's what I was trying to say. So those additional settings that people will be able to change, modify within the AnyConnect config as they open the application. What they will see, what they will not see is going to depend on the profile config. There will be actually 2 additional XML files that AnyConnect uses in the background. It's going to be the user and the global preferences files. The user preferences are just preferences. XML is something that applies to the user itself, versus global is what's enforced before someone logs into the PC, to the device. But it's not something that is really important from the deployment perspective. It's just so people can select if AnyConnect should reconnect automatically or not. Maybe tell if AnyConnect should start when the system boots and stuff like that. Not something that I would say is really critical for the deployment. Okay, so AnyConnect Profile, as I said, is something that we will have to build when we plan to deploy remote access with AnyConnect using the full client approach. And there are actually 3 places, 3 methods as how we can do this. Probably one of the most commonly used method was to go use ASDM, the ASA's GUI. It gives you access to the profile editor. There is one option that gives you access to the editor itself. But as an alternative, or basically for people who don't really want to use ASDM, maybe they don't even have an ASA, but still want to build a profile, you may want to run AnyConnect with iOS, maybe some other device. It is also possible to use the standalone editor, which is something you can install on your PC. You can build a profile and then upload the profile to the head end. And as a last resort, it is possible to manually edit the XML file, even build it from scratch if you know the actual syntax. You can edit the actual profile using any type of XML editor or just a notepad. It is also possible to do this. Right. We will now talk a little bit about the configuration and take a look at the deployment for the ASA and AnyConnect. Just in case you guys want to learn about some additional details for AnyConnect, I would personally take a look at these 2 courses on the INE's website, the Secure Connectivity and Rohit's v5 lab preparation. Even that this second one is for version 5 CCIE, it's still valid, it's still up to date. You'll find some more examples as how to use AnyConnect, how to deploy it with other devices. So it's pretty good. It's pretty good stuff. Something, if you're interested in about AnyConnect, I would definitely go ahead and take a look at these two courses. Okay, let's now talk about let's now take a look at the deployment side. I want to start with a quick overview of what type of configuration we will have to do to make it work. As I said, it's going to be the ASA. What we will focus on today is going to be the ASA, and I will be using the command line to show you how to do the configuration. There will be three main components that you will have to think about when you deploy AnyConnect on the ASA. There is going to be the web VPN settings, which is something global for this is more of like global configuration for the firewall related to SSL TLS. It's actually a pretty good place to start your configuration, because this is where you will tell the ASA what AnyConnect image you want to use, what profiles should be available, made available for selection, and when you define your policy. And this is also where you can change the port number for the actual socket for the connections. This is where you can enable, disable DTLS, maybe change the port number for DTLS, and do some other global changes. Another thing that we will have to think about is going to be the group policy. The group policy obviously is the place where we will define certain attributes that we will be then pushing to the connecting clients. We have to define a group policy. We may use it to specify the protocol we want to allow people to use as they connect. This is where we will, I believe, also activate the actual profile. Yeah, this is where we will also select the profile, AnyConnect profile for the connection. And then the last piece is going to be the tunnel group. And tunnel group is where we will point to the right group policy, and it's also where we will do the specify the authentication settings. So these are the main building blocks you have to think about as you deploy this feature. But some other options that you will still have to take into account is going to be authentication related settings. It's going to be the address pool. AnyConnect, this type of VPN setup, it requires IP addresses to be assigned to the connecting clients. There's going to be an IP address that the public address that people use to build the tunnel, and the private or just VPN address that is going to represent the tunnel on the internal network side. I would also think about split tunneling. And I would also want to make sure that my HTTPS server is enabled on the ASA. Okay, so we will take a look at the configuration in this exact way. The thing is that once people start connecting to your headend, they will be terminating their connection on one of the tunnel groups. And now the tunnel group is gonna point to the group policy with the attributes that we want to then send to the users. And web VPN is where we will also define some of those attributes for the group policy. Of course, this stuff is still relevant, and most of those things are related to the group policy. We have a really simple network build to show you this implementation. I will be eventually connecting from PC1 from this device over here. The goal is going to be to build a tunnel with the ASA, with the outside of the ASA. And we will obviously try to get access to the protected resources connected to the inside of the ASA. It's going to be, this stuff is going to be represented by router 2. Now, before we start working on the VPN configuration, I will want to make sure that we have IP connectivity between the PC and the ASA. So it's always good to see if you can actually get the headend before you start playing with SSL or just IPsec stuff. I would try to get to 192.168.70.120, which is my ASA. We see that I have connectivity. As opposed to if I were trying to get to the inside of the ASA, this is something that my PC is not even know how to get to. I don't even have a route to this subnet. It's a private network that we assume that this guy is not aware of. It's not able to get through the public network. That's why we will build this VPN in the first place. We want to extend this subnet, make it available to the connecting client. Right, and I'm going to start on the ASA with this more of like optional stuff. We will still have to check or just make sure that the HTTPS server is running on the ASA. It should be on by default, but it doesn't hurt to put this command on. Since I will be using, it's going to be an SSL TLS example, what I will be showing you this in this session. When we get to the end, I will also quickly navigate through the documentation to point the differences between the SSL TLS and the IPsec configuration. In our case, it's going to be SSL TLS, and I will do the local authentication. It's going to be username, password authentication. This is why I am adding a single user account on this ASA. We will go for Cisco and Cisco. Then, since the only thing I will want my client to be able to get through the tunnel is the inside of the ASA, I will also enable split tunneling, which means that once the tunnel comes up, so once the VPN is up, the VPN is only going to work for packets destined to this single subnet. So VPN is going to be up, but only for 192.168.21.0/24 subnet. Only those packets will be tunneled, will be sent to the ASA. Everything else is going to go in clear. Now, if you really want to use this feature or not, it probably depends more on your organization's security policy. It's, at least in the past, it used to be a secure. Some people deemed it as a security hole, because if someone was able to compromise your device through the VPN, it would be able to, excuse me, someone from the outside would be able to compromise your PC. It would be able to get access to the internal network through the tunnel. But today, given the cloud, deployments, given the fact that many organizations keep their security policies in the cloud, it's probably not that important. But I will be using split tunneling just for the purposes of not locking out myself of the RDP connection to the PC, to the client device, which means that I will have to define an access list where I will tell it what's the protected subnet. So let's say that my access list is going to be called VPN. It's enough to build a standard access list because the only thing that we care about is the actual subnet, the destination subnet. We don't really care about the source. So I will say that it's just for 192.168.21/24. And one additional thing I will still have to define here. See, we've got the access list, we've got the username, we have enabled the server. I will also have to build a pool that I'm going to use to assign IP addresses from to the connecting clients. So this pool is going to be defined locally on the firewall. I will call it AC pool, like AnyConnect pool. Now let's shoot for 10.5.5.1. That one is going to be the first IP address I want to assign to the connecting clients. The pool is going to consist of, say, 50 addresses. An important thing to remember about as you define the pool is that you want to make it, you want to associate it with a mask. So just to make sure that the people get assigned an IP address and the right address mask. /24 is going to work in my case. Okay, so we know that the server, the SSL server, the HTTPS server is up. We got the local account for authentication. We've got an access list for split tunneling, and we've got the pool. We can now start working on the actual SSL config. We will go to the web VPN configuration mode, and we will play a little bit with the AnyConnect settings. Okay, so ASA must know what AnyConnect image you plan to use and possibly push to the connecting clients. So I will have to tell it that my AnyConnect image is located, in my case, it's in the flash of this ASA, and the package itself is, it's going to be AnyConnect version 4.2 for Windows devices. I only care about Windows clients in my case. Another thing I will have to tell it is what's the profile, AnyConnect profile I will want to use for within the group policy. And the profile is something that you cannot configure on via the command line. As I mentioned, you can either use ASDM, a standalone editor, or you can edit an existing XML file or build it from scratch, which is probably not going to be an option. We will use the standalone method, but what I want to show you is that I already have a profile. I configured it before this session, and I uploaded it via TFTP to the ASA's flash, and the profile is called cells XML. And I'm going to show you that the profile is actually here, and what it contains, we will say more. Now, show me the content of the profile with the more command. And so it's this stuff. It's the actual XML notation. As we will see, the most important thing is going to be to specify the address of the firewall. It's 192.168.71.20. It matches my topology. This is an alias that is going to be visible within the AnyConnect. It's something that people will be able to choose to select the gateway to connect to. And somewhere here, we also tell it that we are okay with IPv4 and IP version 6 being used for transport. The other stuff is more optional and less important. Now, just in case you never created a profile, I will also quickly show you how to do this using the standalone editor on the PC that I have. Okay, we will just go to So the profile is something you can also download from the Cisco's website. In case of VPN, it's going to be the VPN profile editor. What would we want to look at? It looks like that. You've got two parts of preferences. That's the most important stuff, plus the server list. Okay, so let's take a look at it from scratch. Let's go to the preferences. In this section here, you tell what settings people will be able to control once AnyConnect gets installed on their devices. So can they minimize and connect? They want people allowed to change this setting or not. Maybe auto connect and start before logon, that type of settings. An important option that you have to pay attention to here is going to be the Windows VPN establishment. If you plan to use AnyConnect, that's what I do. If you plan to use AnyConnect through a remote session, which in my case is RDP, you will have to allow, choose this option, allow remote users. But otherwise, you will not be able to establish a tunnel. So it's like you're telling AnyConnect that you're okay with establishing a session from a probably remote session. And you can also choose what protocol, IP protocol you want to support for the connection, IP version 4, version 6, or maybe both. Then it's gonna be the, what else? Let's take a look at this. Other bunch of settings you can give people to control. Okay, so automatic VPN policies. Less important stuff. This is well documented in the Cisco's AnyConnect guide, which we will get to in just a couple minutes. Backup servers, that's pretty important. Most people, they want to obviously deploy this feature in a redundant way. And one of the methods is how you can easily do this is going to be to specify IP addresses of multiple devices. Like when you have a backup ASAs, backup VPN servers, you want to add them to this list. And then the server list is where you tell it who's your headend. So this is going to get pushed to the client, as I said, along with the group policy as one of the attributes, because you may want to use different devices, different headends for different, let's say, departments, maybe one for sales, one for finance, but something else for DevOps. This is one of the options, that it's pretty important as you build the profile. What I put over here, in our case, it's going to be set to ASA1. It's just an alias that is going to be seen by the clients from this drop-down list. Then you tell it, you give it the actual address or FQDN of the primary gateway. Okay, backup server list, and then the primary protocol. SSL. SSL is going to do the trick in my case. If you wanted to go for IPsec, you tell it whether the headend is a gateway. Excuse me, you tell it whether the headend is the ASA or something else. And for iOS, you can also specify IK identity and select the authentication methods allowed used during negotiation. Okay, in my case, it's SSL to the ASA. And so this is something that I would normally save. I would give it a name, this is going to be an XML file, as I said. I would just give it a name, and this is something that you would have to upload to the ASA, to the VPN server. Now, I will not be doing this because I already have one, and it has the same exact settings as what I was just showing you. So we will be connecting to our ASA. It's going to be listed as ASA1, and I'm okay with IP version 4 and IP version 6 transport. The SSL is the default option. I believe that this is the reason why the protocol is not shown on this within this profile. Okay, I go back to the config. Let's take a look at, let's see what we've done so far. We just got the image. Now we will say, we also have the profile. In this case, in this step, what you tell it is how you want to alias the profile for the selection within the group policy. Since I will be building a tunnel for people grouped as sales, I'm gonna simply call it AC sales, AnyConnect sales. This is just a name, an alias for my profile. Okay, and the profile file is here. It's on the ASA, it's sales XML. Show run web VPN. Okay, we will still want to enable AnyConnect on this device. An important setting is going to be to configure to allow people to select the group they want to connect to from a list. And that's the purpose of the tunnel group list enable command. We will get back to it as we test this setup. And now I will just say enable. I want to enable my SSL TLS VPN on the outside of the ASA. It's this interface over here. You go O. If I were to say TLS only, it would automatically disable DTLS. But most people, they want to use both. They want to use DTLS for UDP-based applications such as VoIP, and they want to use TLS for TCP. So we will say enable outside. It is also possible to customize the default port numbers, because by default, it's going to be listing or 443. I can use port to change the TCP, a socket, and I think I can also use DTLS. I can have a separate one for DTLS using the DTLS port command. But we will stick to the default values. Okay, I've got the VPN stuff taken out of the route. We will now build a group policy, a sales POL. It's going to be defined locally on this unit. It's going to be defined in the configuration of this ASA, and the policy is going to look like that. We build our attributes. Okay, so first and foremost, I want to tell it what's the address pool I want to use. Address pool, you have to tell it what's the pool name. What's the pool name? I think it was called VPN. Okay, let's just do this. Let's just say, I will say VPN, but I'm gonna say, okay, it doesn't exist. Showdown IP local pool. AC pool is the name. I've got the address pool. This is so I can allocate addresses to the connecting clients. You could do better if you wanted. People would have to accept the banner to get connected. We will also say that the domain, we want to set it to INE.com. Anything else, domain is optional. Split tunneling stuff. The split tunneling configuration consists of two elements. First thing, I want to tell it what method I want to use for tunneling, which is split tunnel policy. And I will say that I want to tunnel only networks specified by the split tunnel network list. So split tunnel network list is another thing I have to tell it, which is and the value, the access list was, what was the access list? The access list was called VPN, not the pool. right? I've got the split tunneling stuff. I've got it in place. We've got split tunnel, policy, list, optional domain, address pool, anything else. Or I may want to tell it that I want to restrict people to use SSL, full client. That's my goal. And then at the end, we will still have to take a look at the SSL TLS attributes. Okay, so we will have to look at this option. Everything else is going to be optional, but there is one AnyConnect option that we have to choose, which is to tell it what profile we want to push to the connecting clients. I called my profile AC sales. I can now select it from the available packages. So this is pointing me to cells.xml on the in the flash. To this file, just based on how we did the web VPN configuration. When I was playing with web VPN options, I said that I want to make sales XML available to the policies via AC sales. Let's look at the policy once again. The protocol, split tunneling, address pool, domain, and AnyConnect profile. Okay, the last piece is gonna be to build a tunnel group. And a tunnel group name, it's not really important what name you specify here, because we will use aliasing and make those tunnel groups available to the connecting users through a special list that will be that people will be able to choose from via AnyConnect. So I will show you what I'm thinking about. I'm gonna call this group TG1. It must be type of remote access. Remote access is for IPsec and SSL TLS VPNs. And there will be two types of attributes that we will have to specify for the tunnel group. Now, TG1 is going to be a valid group. So I will start with general attributes. And I will have to tell it how I want to authenticate the connecting clients. So in my case, it's going to be the local database authentication. This is why I added a single user account on this unit. And I will have to tell it what's the group policy. Where do I store my attributes that I will be sending to the connecting clients? And I called policy sales POL. I think is the name. Show them group policy. A sales POL is my policy name. Okay, that's the minimum config in the under the general attributes. The authentication server group set to local is the default, so we don't see it here. But one additional thing we will have to do is going to be to look at web VPN attributes. Okay, so what do I have to specify in here? Authentication. This is how I tell it that my clients will get authenticated simply via a username and a password. Alternatively, you could do certificate-based authentication for the clients, or you could even do a multi-factor authentication. You could use more than one authentication method if you were to say that you want to use AAA and certificates. Just one method in my example, and then group alias is, this is exactly what we will display on the AnyConnect in the dropdown in the drop-down list for a group selection. So I will alias this as sales. We will double check the config of the tunnel group. And we will still add one more tunnel group just to show you that drop-down menu list. So I will build a dummy. This is fake. It's just to show you that, it's just to show you how aliases work. Remote access. Web VPN attributes. Just give it a different alias. DevNet. Okay, so this is fake. I just added it to show you the difference as we connect via AnyConnect, using AnyConnect. Okay, so let's quickly recap on this config. We've got the global web VPN settings where we enable, where we activate the socket, SSL socket, SSL and SSL TLS and DTLS socket. We tell it what's the image, what's the AnyConnect software. We will be, people will be able to download if that's the method of the AnyConnect installation we selected. We defined a profile and uploaded it to the ASA via TFTP. The profile was defined using the standalone method. We enable AnyConnect. We enable the selection of the, this is how you enable the dropdown menu list on the AnyConnect. We will look at it in just a moment. We build a group policy with our policy attributes, including split tunneling configuration, including the domain name, address pool, and we said we want to use this particular AnyConnect profile for connections to this group. And then the last thing was to build a tunnel group, which is something that we will, the ASA is going to eventually use to terminate the connections from the users. If the connection terminates on group TG1, which is aliased as sales, we will push those attributes. Okay, so as we connect, the goal is going to be to choose sales from the drop-down menu list. When I choose sales, it means that I will be technically using this tunnel group for the connection, which in turn means that I will be pushing those attributes for the users. VPN attributes. Right, let's look at this on the client side. So let's assume that this is a brand new setup. I don't have a profile from any previous connections. I will just have to tell it what's the address of the ASA, of the headend. And I would say connect. So this is my first connection with AnyConnect. The certificate is not trusted in my case. It's something that you would want to change in the preferences here. The block connections to untrusted server option is by default checked, which would prevent the people from establishing a session with the device that has an invalid certificate. So I want to uncheck it because my ASA is not something that the certificate of the ASA was self-signed, which means that the client is not able to validate it. It's not part of the underlying ASA's PKI, but that's fine for the demonstration. I'll go back one step. I said I want to connect to 192.168.7.120. Okay, so that's the drop-down list I was talking about. That's what you activate via the What command? Tunnel group list enable. This is what makes this list visible on the clients. And I can choose DevNet, I can choose sales. If I choose sales, it means that I will be technically connecting to the TG1 tunnel group. So I will be pushing those attributes, this policy, to the connecting clients. Okay, I'm choosing sales, and I want to authenticate as Cisco. Okay, it says we are connected. It's always a good idea to double check the statistics and the session information on the client side. And what's going to be important in our case is going to be to look at the route details. We see that the only traffic that is going to be secured is for this subnet. It's communication destined to this subnet, VLAN 21. So when I try to get to router 2, which is in VLAN 21, we should have connectivity. I believe that this stuff here, this is when the DTLS tunnel is being established. But we see we have reachability, and when I telnet to router 2, which once again is in VLAN 21, it's this device here. We see that I have connectivity, I am connected, and I appear to be coming from the IP address that was assigned from the pool. Let's double check this. Let's say show IP local pool on the ASA. We see that just one address was assigned, which is 10.5.5.1. 49 addresses left. Okay, so it's definitely the VPN address what we use as we connect. You could also take a look at some other statistics here on the client side, like check the actual counters. So it says that's the public address of the server. That's the headend. This is my logical address of the client. This is the amount of bytes sent via the tunnel, amount of bytes received via the tunnel. Also the actual numbers of packets. Okay, so pretty useful stuff on the AnyConnect on the client side as well. And obviously on the headend, in my opinion, the easiest way to verify that type of connections is to use the show VPN a session database command, show VPN session DB with the AnyConnect option. So this is giving you a summary of AnyConnect connections to this headend. It says that the user Cisco is coming from a device configured with this public address, 172.189.200, and got assigned this VPN address. So this user is visible as 10.5.5.1 on our internal network. It's cryptographic information about the cryptographic functions. It's information about the licensing. It's the information about the packets sent, received via the tunnel. It's the actual policy we enforced on this connection, timeouts, and some other data. You can also take a look at the actual tunnels when you add the detail option, show VPN session DB detail, AnyConnect. In this case, we will also see the information about the tunnels themselves. Notice that it shows us actually 3 tunnels. We've got the parent, which is more of like a summary of the connection. So it's the public address of the client. It's the transport information, the port numbers, the socket, the information about the operating system version, the client, and then we see the TLS. This is TLS stuff. This is DTLS. So this is for UDP communication. This is for TCP. Okay, just one more thing I wanted guys to show you before we get to Q&A. Let's take a look at the main documentation page. Let's go to security. The most important documents, the documentation that is related to AnyConnect, you can find it under AnyConnect Secure Mobility Client. And we will also look at the ASA configuration guide for a second. ASA, I'm looking for security guides, configuration guides. Configuration guides over here. Let's shoot for 9.8 VPN CLI. A site-to-site and client VPN, and then down to remote access IPsec VPNs. Configuration examples for IPsec. So I want to show you the difference between SSL TLS config and IPsec. In case of IPsec, it will in general you add on top of what I just showed you here. The exception is going to be that you don't do any type of, let's do it once again. We've got web VPN stuff, we've got group policy, and we've got the tunnel group. So the main difference is that you don't do web VPN. I'm talking about pure IPsec. You may still need it, like if you plan to do the network download for AnyConnect, but just for IKEv2, IPsec, you need the group, you need the tunnel, and then you need the IKEv2 policy. You need to enable the protocol on the interface. You still need the pool and authentication stuff. Then you need a transform set, or just proposal, and a dynamic and a static map. So dynamic map goes to the static map, and static map is what goes to the interface. So that's the very high level overview of the differences between SSL, TLS, and IPsec config. And one more thing I want to show you is some of the AnyConnect documentation. Let's take a look at. Yeah, I will look at the design, and there is also one that shows you some performance and scaling config you might be interested in. So this is I guess they created it for the virus stuff, the COVID. It's talking about the performance impact, optimization of the AnyConnect deployments, like the hardware engine acceleration, stuff like that. And then the design document. This is pretty good stuff. They show you it's really cool for redundancy, for high availability. I think it's where they show you the actual HA scenarios, design choices for remote access, like how you do active standby failover, how you do load balancing, and then when you kind of like use both methods in the same time. to even make the whole deployment more redundant. Okay, these two courses, as I said, is something I would definitely want to look at to learn more about this feature. Let's see if you guys have any questions. Let me pull up the Q&A. Okay, I see some questions. I've got a Cisco AnyConnect remote access VPN. However, when I connect remotely, I cannot launch ASDM. I would go ahead and say that you probably want to look at the port numbers. You want to make sure that it depends on the version of the ASA, but I would look at the port numbers used by ASDM versus SSL. I'm wondering how AnyConnect works when the standby is active and connected to a backup link. Well, I guess this is a question about active standby failover. So when you do active standby, a VPN sessions is one of the things that gets replicated from active to standby. And I think that they also mentioned this somewhere in this document. So this once the replication works properly, the device would, since the IP address remains the same, it should actually work via the standby device as well. Okay, we've got how many users can download the Cisco AnyConnect client. This is more of like a licensing question, I guess. I'm not really sure if the license limits the amount of downloads. I don't think it does that, but the headend is going to limit the number of the clients that can connect to this headend. So if you're licensed for 250 users, even that 500 users can download the software, it's still going to be 250 who can terminate the tunnel on the headend itself. The AnyConnect uses SSL by default. You can use iOS device as a headend as well. It's definitely supported. You can do IKEv2 IPsec with iOS, and you can do clientless SSL TLS with iOS. But I don't remember off the top of my head if you can do SSL TLS AnyConnect with iOS. This is something that I think that you can do this, but I'm just not 100% sure. The licensing question, this is something that unfortunately I will not be able to give you the answer. I just don't remember what are the differences between the different types of licenses. So this is something that I would normally check in the, hold on a second. Let's see if they mentioned something about licenses here. Okay, this is in French. Yeah, licensing information. So I would just look at this section. It is possible to use a different client than AnyConnect, because most operating systems today, they come with a certain remote access clients pre-built, at least Windows. You've got what is known as a Windows IKEv2 client. But this requires some special configuration on the headend. In terms of the DTLS resources usage, what I was trying to say is that DTLS performs some more advanced calculations in the background comparing to IPsec, and just based on the fact that most headends are by default optimized for IPsec, it may give you some worse performance comparing to if this was just IPsec based VPN. In terms of security, TLS, SSL versus IPsec, I think that first and foremost, it all comes down to the protocols that you want to use, and you allow to be negotiated between the client and the server. Now, in case of SSL, TLS, we say show run all SSL. The SSL command is how you can control what the headend will accept for the session. So what type of cryptographic functions you will want to use when you negotiate with the clients. So for instance, if the client was trying to use SSL version 3.0, I don't have it on the cipher list here, the headend would never build SSL 3.0 connection with the client. So we can control, it's probably about the actual functions that you will select as you build the connection profiles. And there is also this vulnerability factor that you need to take into account. So it may turn out that IPsec has some flaws at some point. It might happen. It might be the same for SSL TLS. So this is something you just have to watch out for all the time. But other than that, it's always going to be the actual functions, ciphers that you select. Do we need administrative rights to install AnyConnect from the web portal? I'm pretty sure you need those when you do thin client, like when you go for the Java applet. Hold on a second. Let's take a look at configuration guides. Let's say 4.7 and deploy. And let's look for privileges. Yeah, it looks that you will need those admin privileges to install AnyConnect. Okay, guys, I see that we still have some other questions. And unfortunately, my time is somewhat limited today. I'm gonna write down all of the questions you guys sent today, and I will get back to those questions. I will get back to you with those questions, with the answers to those questions personally. I mean, individually, because I'm not able to answer all of those questions today, unfortunately, which I wish I could, but it's not the case. So thank you everyone for joining, and I appreciate everyone taking the time to be with us today. And I'm hoping to see you guys in another webinar from INE. Thank you.